this one would be referred to as a very wide or fat scaling. It makes for a very airy tone when you have a wide scaling, and that lends itself to a flute sound. And so you get a flute pipe. But if you were watching, this one has a cap. It even has a chimney on it that I took off. Now what happens when the air enters and it goes to the top and it cannot escape? It has to travel back down to come out the mouth of the pipe. So the length of the column of air that's resonating is actually double the length of the pipe. So it's going to sound like a pipe that is twice this tall. So listen to that. It's almost exactly an octave difference in pitch because the air had to travel twice that length. And flute pipes especially have all kind of caps, chimneys, stoppers, all different shapes on the top. And flute pipes can also be made of wood. Obviously it's not round, but the wood makes for a very mellow tone. So you get wood. Here's another kind of flute pipe. And I've been telling the other classes, if you're really interested in the organ and you're really interested in science of all kinds, the greatest amount of scientific knowledge that goes into an organ is in the person who is the pipe maker. Because you've got to know what, you can look at these and see all different mixtures of metals to get different finishes and different sounds. You've got to know what kind of shape will create the tone quality you're wanting. Do you put a stopper or a cap? A great deal of scientific knowledge goes into making the pipes to get the kind of sound you want. But all those are different flute sounds. Every different division or room in the organ will have principal pipes. It will have flute pipes. It will have all the different kinds. So what I'm going to do is play a little bit of a piece for you by Louis Daquin, French composer. This would have been written in the early 1700s. It's a Noel, a Christmas song, and it bounces from place to place. So I'm going to show you all the different kinds of sound you can get from flute pipes. Okay, now, I talked to you about principles and flutes. There is one more way you can make a pipe, one more kind of pipe. If you will look at this string pipe, in comparison to the principal, this one would be called a very narrow scaling. It's taller than the principal pipe, but much smaller in diameter, and it even tapers toward the top. And this pipe I want to use and show you what a difference it makes if you don't have a constant wind pressure. That keeping the constant wind pressure is essential to keeping it in tune, to having a consistent tone quality and things like that. The string pipes are more temperamental if the wind pressure changes than anything else. And I want to just take this pipe and show you all the different sounds I can produce just by blowing at a different pressure. You can change just by changing the pressure of the air entering the pipe. They're very temperamental. So I'll take this chance to remind you that the organ, which is the oldest recorded instrument, the first written record was in 326 BC. Cestibius of Rome. It was used the pipe organ for gladiator matches. And that's how the organ first was introduced, things like gladiator matches. It would have been a small organ, probably not a lot larger than this little case here. It would have sat on a table and someone would have pumped the bellows by hand to get the air into the pipes. As organs continued through the centuries, and by the way, it was like 1600s before it really caught on that the organ could be used in church. It was considered an evil pagan instrument because it had been used in things like gladiator matches. So it's newer in the church. But even newer is electricity. If you think about since 326 BC till now, electricity is a new thing for the organ. And up until that time, all those years, someone or many someones had to pump bellows to get the air in. In the 18 and 1900s, organ building really developed, and organs in Europe were large in the cathedrals, and it's recorded there may have been as many as 24 people simultaneously pumping bellows to have enough air to keep the pipes plying. So if you think about that, this electric blower motor that we have here, we turn a switch and it blows and keeps the air at a constant regulated pressure. And so that's a bigger deal than it sounds when you first mention it. But the string pipes are really susceptible. Now, another cool thing about string pipes, you never ever have just one set. You always put two sets of string pipes identical, and you place them side by side in the organ chamber. The first set you tune with all the rest of the organ. The second set you tune slightly sharp. Every note is tuned a little bit higher in pitch than the partner note in the first set. So you have these pipes that are playing, and their sound waves are almost the same length, but not quite. So they're constantly fighting each other to try to line up, and they can't line up. And the term we use in organ is beating, because when they're trying to line up and they're not, you're hearing this wah, wah, wah kind of sound. And I want to play that for you and show you how that works.